Hello class, we're going to talk about sampling distributions now. We're going to do this in preparation for section 7.5 on the central limit theorem. The central limit theorem is perhaps the deepest theorem in all of statistics, so it's certainly going to be the deepest thing that we cover in class this semester. So let's say we start with a distribution of x, a particular variable, and a set x has many values, and it comes with a mean mu and a standard deviation sigma. So what we're going to be looking at is coming up with a new distribution from this one. So we're going to make a new distribution which we're going to call an x bar distribution. And each element in this new distribution is going to be, well, what's x bar? X bar is a mean. So each item in our new distribution is going to be a mean of items from our original distribution. So from x, we're going to take samples of size n. The mean of each sample is going to be a value for x bar. So we start with a distribution of x, and from that we're going to make samples of each of size n, and we take their average. So we have a new set of values, and we're going to call that the x bar distribution. It too is going to have a mean and standard deviation. We're going to call the mean mu x bar, and we're going to call the standard deviation sigma x bar, just so that we can tell them apart. This is also called the standard error. So we started with one variable, we started with an x distribution, and we used sample means from that to make a new distribution. So now we have a new distribution based on samples from the original one. So let's look at an example, and let's say we have a bunch of oranges, and okay, so we have each of these oranges, and let's say that these are from, and each our variable x is going to be the weight of an orange. And what we'd like to do, instead of considering the weight of an orange, we're going to take a sample of size 9, for instance. So we're going to look at this sample, size 9, and we're going to take that value. So instead of x, we're now going to consider x bar, and this is going to be the average of a weight per 9. So instead of looking at the weight of each individual orange on their own, we're going to make groups of 9, and we're going to take the average. So we have these 9 oranges, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to take the average, and that is going to be one new x bar value. Okay, so the reason we do this, a couple reasons. Sometimes this is easier than weighing each item, for finding the value for each item. It's sometimes easier to group them, and sometimes you actually care about the grouped value. You might actually care about x bar. Let's say in the case where you are a distributor for oranges, you actually might care that each box of 9 oranges is about the same weight. Sure, some of the oranges in the box might be bigger, might be smaller, but you want to know that each box has about the same weight, so maybe you care about what the average weight of an orange is in the box, not necessarily whether each orange is the same. So that's an example of how we use a sampling, how we could create a sampling distribution. You take samples of a particular size, find the average for that group, and that's going to be your new data value. Okay? So now that you've listened to an example of a sampling distribution, take a look at the central limit theorem the central limit theorem video next. Okay? Take care.